In this video, we will be working through the process to create the Simple Bookshelf project. This project consists of 15 parts. Part 1 is to create the left and right sides. Part 2 is to create the bottom shelf. Part 3 is to create the bottom gussets. Part 4 is to assemble the carcass of the project. Part 5 is to create the top rear rail. Part 6 is to create the front stiles. Part 7 is to create the bottom rail kick plate. Part 8 is to create the top front rail. Part 9 is to do our first assembly. Part 10 is to create our top gussets. Part 11 is to create the top. Part 12 is to work with the pilasters. Part 13 is to create the back. Part 14 is to create the shelves. And part 15 is our final assembly. Our project plans consist of 2 sheets. The first sheet is our multi-view drawing, and the second sheet is the exploded view of our project. Taking a look at our plans, we can identify both the left and right side. The total depth of our project is 13 inches. We do have a 1-inch overhang, which then brings the base of the project to a total depth of 12 inches. Now we also have a 3/4 inch thick face frame, which will bring the left and right side down to 11 1/4 inches. The height of our left and right side is 47 1/4 inches. And this is using 3/4 inch oak veneer plywood. We do need 2 of these. If we take a look at our cutting diagram for plywood, we should be able to get all 3/4 inch plywood components out of a half a sheet of plywood. So this project will begin with 3/4 inch thick oak veneer plywood and a half a sheet, so it is measuring 48 inches by 48 inches. Taking a look at the rendering of our finished product, we can see that the grain is running vertically. It is also running the same direction as our length measurement. If we take a look at our plywood sheet, that 47 1/4 inch measurement needs to go with the grain. On our plans, the depth measurement is 11 1/4. So on our plywood, we will want to rip this at 11 1/4 inches along the length of the grain. And because we have 2 sides, we will need to make 2 of these cuts. This also correlates to our cutting diagram for plywood. Taking a look at our plans, we have a width of 12 inches for the base of our project. We do have 3/4 inch thick face frame. With that face frame removed, that leaves 11 1/4 inches for our left and right side. On the table saw, we will set our fence to 11 1/4 inches. And we do want to make sure that we are cutting with the grain, so that grain is running the long way on our project. When finished, I have 2 pieces each measuring 11 1/4 inches wide by 48 inches long, because that's half a sheet of plywood, by 3/4 inch thick. Taking a look at my plans, I can see that the sides of my project, both the left and the right, measure a total length of 47 1/4 inches. To set up a stop block for the miter saw, I'm first going to measure my 47 1/4 inch length, and I'm going to line that up with my saw blade. And on the other end of my board, I'm going to install a stop block with a square end and 2 clamps. I can then move the miter saw head nice and slowly through my material. This will prevent chipping of the veneer. And this process can be repeated for our second side. When finished, I have my left side and my right side. They measure 11 1/4 inches wide by 47 1/4 inches long by 3/4 inches thick. Taking a look at my schematic, I have one bottom shelf. This shelf runs from the left side to the right side, and it fits between these sides. My total width of the project without the top is 24 inches. My left and right side are 3/4 inch oak veneer. So if I take my 24 inch width measurement and I subtract the thickness of the left side and the right side, that gives me a length of 22.5 inches. The depth of our project is 12 inches. My face frame is 3/4 of an inch, but I also have a 1/4 inch back on this project. So 12 inches minus 3/4 for my trim and a 1/4 inch for the back gives us our 11 inch width measurement. Now if I take a look at my plywood cutting diagram, it appears as though the bottom shelf and the other shelves are all identically the same size. That is only partially true, because if we take a look at our schematic, we do have pilasters that our other shelves sit on. Those shelves will end up being a little bit shorter than the bottom. Something to keep in mind as we plan this out. With my remaining material from my half a sheet of plywood, I need to get the bottom shelf as well as 3 additional shelves out of this material. Looking at my parts list, the bottom shelf has a width of 11 inches. Additionally, my other 3 shelves also have a width of 11 inches. And again, this is because the side of our project is 12 inches minus 3/4 of an inch for our face frame and a 1/4 inch for the back. If I rip this piece to 11 inches on the table saw, this will be acceptable for both my bottom shelf as well as my other shelves. Taking a look at my schematic, the width of my project, not including the top, is 12 inches. The face frame is 3/4 of an inch thick, and my back is 1/4 inch thick, according to my notes on the schematic. Setting my table saw to 11 inches and ripping my remaining material to that 11-inch measurement will yield me the material that I need for this one bottom shelf. And what I am left with is one piece measuring 11 inches wide by 48 inches long by 3/4 inches thick. Taking a look at my schematic, my bottom piece fits in between my two side pieces. Because the total width of the project, not including the top, is 24 inches, and my sides are 3/4 of an inch thick veneer, I can take 24 inches, subtract 3/4 of an inch for the left side, 3/4 of an inch for the right side, and that gives me a total length of 22.5 inches. And because I only have one of these pieces, it is not necessary to set up a stop block. So I'm going to measure this to a length of 22.5 inches, mark it, and then very slowly make my cut. I am then left with my one bottom shelf, which measures a length of 22.5 inches, a width of 11 inches, and a thickness of 3/4 of an inch. Taking a look at the exploded view of our project, the bottom gussets are located underneath the bottom shelf. These bottom gussets are what will take the load of that bottom shelf. They are designed to go on the inside of the project behind the face frame. Taking a look at our parts list, we can see that the bottom gussets need to be 2 1/4 inches wide by 11 1/4 inches long. Additionally, having a thickness of 3/4 of an inch. By selecting a board that has a width of 5 inches, I should easily be able to get two 2 1/4 inch wide pieces out of this, with leaving me a little bit of extra material for cleaning up the edges of this board. Now this board has a knot on it, but I am not concerned with that because these gussets go underneath the project where no one sees. My bottom gussets need to be a length of 11 1/4 inches. This will allow those pieces to fit behind the face frame at the bottom of the project, hidden away where they cannot be seen. The end of my board has a couple issues. Number one, it is not square, so I need to make sure to square this up on the miter saw first. Additionally, I have a corner that doesn't look very good. However, this is not an issue because if I lay out both of those gussets, I might not even get to that corner. Additionally, since this will be planed down to 3/4, that piece should be eliminated. So my first cut will be to square it up. Now, although my finished size is 11 1/4, I'm going to add just a little bit of extra material because I still need to clean up the edges and the faces of this board. So I'm going to measure and mark this at 11.5 inches and then perform that next cut. I now have one board that measures right at about 5 inches wide by 11.5 inches long, which is my oversized measurement. This board is about 1 inch thick, and it should yield me enough material to get both of my bottom gussets with just a little bit extra material to spare. Taking a look at my schematics, I have 2 bottom gussets which fit on the inside at the bottom. My parts list identifies these pieces as 3/4 inches thick, 2 1/4 inches wide, and 11 1/4 inches long. Taking a look at my board, I have one bad corner, so I want to try to get both of my gusset pieces from the other side away from this corner. Now, as this board sits, I have a rough edge and I have a straight lined edge. Because my straight lined edge is on the side with that bad corner, I'm going to go ahead and joiner the rough edge a few times to clean that up. I now have one good, clean, jointed edge and one straight lined edge. My finished width is 2 1/4 inches. However, I'm going to add an additional 1/16 of an inch so I can joint that off after it's been table sawed. And with my good, clean, jointed edge up against the fence, I can make my first cut. With my boards, I have one good, clean, jointed edge. I have 2 mill-marked edges from the table saw blade, and I have one straight-lined edge from the lumber mill. So I'm going to clean up both of my mill-marked edges on the joiner. And that will leave me with 3 good, clean, jointed edges and one straight-lined edge. I have one piece that measures a finished width of 2 1/4 inches, and I have my additional material to get my other bottom gusset piece out of. And another pass on the table saw at 2 5/16 will yield me that oversized width, which will then give me my 3 good, clean, jointed edges and one mill-marked edge. That mill-marked edge, I'm then going to run through the joiner. And that gives me my 2 bottom gussets with a finished width of 2 1/4 inches. These are cut oversized at 11.5, and they are still at about an inch thick. Taking a look at my schematics, I have a finished length of 11 1/4 inches for both of my bottom gussets. We can see on the exploded view that these 2 bottom gussets need to go inside underneath, covered by the face frame. They run directly behind the face frame to the very back of the project. The ends of my board might not be perfectly square because when I previously cut it, the edges of my board were not perfectly square. So I'm going to mark both ends of my boards, take off as little as possible to guarantee that the end is square. Measure 11 1/4 inches from my good end. Set up a stop block to that measurement, and then make both of my cuts. Double checking that we are cutting off the pencil marked end of our board, not the good end. We now have both of our bottom gussets that measure a finished width of 2 1/4 inches by a finished length of 11 1/4 inches. We are still at about 1 inch thick. Taking a look at the exploded view on our schematics, we can see our 2 bottom gussets fit underneath, hidden away on our project. If we take a look at the parts list, we have a thickness of 3/4 of an inch. Because one of my boards has a bad corner, I will be planing a lot more material off of this face to bring this down. But either way, I will be planing both sides of both pieces. And with both planed, my bottom gusset pieces are looking pretty good. I am sitting at a finished thickness of 3/4 of an inch by a finished width of 2 1/4 inches by a finished length of 11 1/4 inches. Taking a look at our schematic, we can see that the bottom gussets fit behind the face frame. They have a length of 11 1/4 inches. So if we look at the right side view of our project, the bottom gusset runs all the way to the back from directly behind the face frame. And those gussets should fit right onto the sides. Now at this point, we do need to determine which side we want facing out on the project, because our gusset pieces are going to be adhered to the inside of the project. We then want to add a little bit of glue to the face of our bottom gusset and spread that around across the entire face. We can flip that over and apply a couple clamps to hold that securely in place. We do want to double check that we are perfectly flush with both the bottom of our project as well as what will become the front of our project. And then wipe any glue that has squeezed out. This can then be set aside for 24 hours. And we need to continue the same process with our other side. Taking a look at the exploded view of our project, we can see that the bottom shelf fits on top of the gussets, and that goes between our two sides. With the glue dried on our bottom gussets, we can dry fit the bottom shelf in place just to make sure everything lines up. And if you remember from the parts list, our left and right side are 11 1/4 inches, but our bottom shelf is only 11 inches. And we can see that when we dry fit this together. That will accommodate our back 1/4 inch veneer sheet and give us something to adhere that to. This also means that when we glue this up, the front of our project needs to be perfectly flush. We also need to determine which side of our bottom shelf we want people to see. And we need to make sure that is facing up. With everything looking good, I can fold my project back down, apply a little bit of glue to the top of that bottom gusset piece, as well as a little bit of glue on the side where my bottom shelf connects to it. Doing this for both pieces. I can then very carefully assemble this together and install one clamp on the back with just a little bit of pressure. Flip our project over and install another clamp. And we want to double check that the front edge of our project is perfectly flush, meaning the front edge of the bottom shelf is perfectly flush with the front edge of both our right and left side. We can then wipe any glue that might have squeezed out. This will then need to sit for 24 hours. Taking a look at our schematic, the top rear rail cannot easily be seen. If we look at the exploded view, we can see that it sits up inside all the way at the top towards the back of our project. This piece has several functions. Number one, it ensures that the two sides remain perfectly parallel to each other during the build process. Number two, this does give us something to adhere the back 1/4 inch panel to. And number three, when this bookshelf is installed in a home, this could serve as an anchor point to anchor the bookshelf to the wall, similar to what is shown on this cabinet. The measurement of our top rear rail is 3/4 of an inch thick by 2 inches wide by 22.5 inches long. And we do want to verify this measurement by measuring between the left and the right side at the bottom of our project. That should measure 22.5 inches. The board that I grabbed earlier in the project was about 5 inches wide. Because I only need one top rear rail piece that measures 22.5 inches long by 2 inches wide, I'm going to be left with additional material. Now if I take a look at my parts list, I have a top front rail piece that is 2 inches wide by 20 inches long. So the remaining material I should be able to get this other piece out of down the road, thus minimizing my waste. Taking a look at my plans, my top rear rail piece runs from the left side to the right side. This is a distance of 22.5 inches. I'm going to measure and mark this at 22 3/4 inches. This is an oversized measurement, and then make my cut. This leaves me with one board cut to an oversized length of 22 3/4 inches. I have a width of about 5 inches and a thickness of about 1 inch. Taking a look at my plans, I can see the top rear rail all the way up at the top in the back inside of my project. On my parts list, it is identified as being 2 inches in width, and currently I am sitting at about 5 inches in width on my board. I am going to get both my top rear rail out of this piece, as well as one additional piece later on in the project. My board has one straight lined edge and one rough edge. If I flip the board over, I can see that I do have a knot on the board. I don't want this as part of the project. That knot happens to be on my straight lined edge, so I'm going to go ahead and joiner my rough edge 2 or 3 times until that's cleaned up. And I'm then going to set my table saw to 2 inches plus 1/16 of an inch so I can joiner off that milled edge once it's been cut. And with my good, clean, jointed edge up against the fence, I can make my cut. So I'm left with my top rear rail. This has one good, clean, jointed edge and one mill-marked edge from the table saw. And then I have my remaining material that I'll use later. I'm going to joiner my mill-marked edge, which will bring that down to 2 inches in width. And I am now at 22 3/4 inches long by my finished width of 2 inches by about 1 inch thick, this being for my top rear rail. Taking a look at my schematics, my top rear rail runs the entire width of the inside of my project. If we look at our parts list, the finished length is 22.5 inches. If you remember, we previously cut our piece to 22 3/4, which was an oversized measurement. We want to make sure that both ends are perfectly square, so I'm going to mark both ends of my board. My first cut will take off as little material as possible. I then want to mark 22.5 inches and complete my second cut. Because there is only one of these pieces, we do not need to set up a stop block. This leaves me with my top rear rail at a finished width of 2 inches, a finished length of 22.5 inches, and my oversized thickness of about 1 inch. Taking a look at my parts list, my top rear rail has a thickness of 3/4 of an inch. Currently, I am sitting at my finished width of 2 inches, my finished length of 22.5 inches, and an oversized thickness of about 1 inch. With the thickness planer, we can plane both sides, slowly bringing the machine down, measuring our board routinely until we get down to 3/4 of an inch thick. This then finishes our squaring process, and our board is 3/4 of an inch thick by 2 inches wide by 22.5 inches long. These are our final measurements for our top rear rail. Taking a look at our schematic, we need to attach the top rear rail to both of the sides. Now the issue is we have end grain that we are trying to connect to our plywood sides. Because end grain doesn't glue, we need to add some mechanical fasteners. We could put some fasteners in from the outside of the project, but then we would have to figure out how to cover up the holes from those fasteners. So instead, we will be adding a couple pocket hole screws from the back side. And our objective is to space out the pocket hole screws so we have a good connection point along the width of this piece. And with our piece squared up to the finished size and our pocket holes cut, we are ready for installation. Taking a look at our schematic, our top rear rail goes all the way towards the top on the inside between the left and right side. We can dry fit this together on our project to see how it will be installed. We want to make sure that the pocket holes are facing the back of the project or facing what would be the wall, but we also want to install this 1/4 of an inch inside from the back edge of our project. And again, this will accommodate our 1/4 inch backing piece and give us something to nail to. And we can install 2 pocket screws. And with those screws installed, our top rear rail is done. Taking a look at our schematic, we can see both of our front stiles, which run the height of our project. The height of the project without the top being 47 1/4 inches. The width of each of these stiles is 2 inches, and the thickness is 3/4 of an inch. Of the material that I have left, I have one board that measures 50 inches long by about 5 inches wide. Additionally, I have one of my offcut pieces and my remaining plywood. Out of my 50-inch length board, I should be able to get both of these 2-inch wide front stiles. Taking a look at my schematics, I can see that the finished length for my front stiles is 47 1/4 inches. I have previously squared up the end of my board in a different step for making a different piece for this project. So I'm going to measure and mark my board to an oversized length of 47 1/2 inches. And then make my cut. And that will give me a board measuring 47 1/2 inches in length, which is an oversized measurement, by about 5 inches in width, by about 1 inch thick. Taking a look at my plans, I can see that my 2 front stiles have a width of 2 inches, and my board currently has a width of about 5 inches. If I flip the board over, I do notice that there is a little bit of a defect on the edge of the board. So if I start on the other edge to get my 2 2-inch pieces, I can hopefully eliminate much of this defect. That, and with planing it, should get rid of this altogether. Now that defect is on my straight lined edge. My other edge is rough, so I'm going to run this rough edge through the joiner a couple of times until it's cleaned up. This will leave me with one good, clean, jointed edge and one straight lined edge. So I'm going to set my table saw to 2 inches plus a 1/16, and with the good, clean, jointed edge up against the fence, perform my first cut. And what I am left with is one good, clean, jointed edge, 2 mill-marked edges from the table saw blade, and one straight-lined edge. I'm going to joiner both of my mill-marked edges. This will bring one of my stiles down to my finished width of 2 inches, and my additional offcut piece material will be prepped for running through the table saw again. And then that offcut piece can go back through the table saw with the good, clean, jointed edge up against the fence. And then we'll clean up that mill-marked edge on that second stile. And at this point, I have my 2 front stiles. They are about 1 inch thick by 47.5 inches long as an oversized measurement by my finished 2-inch width measurement. My finished length for the front stiles is 47 1/4. Our current oversized measurement is 47.5 inches. And now that we have cleaned up the edges of this board, we can bring this down to our finished measurement of 47 1/4. We can start by marking both ends of both stiles. Our first cut on the miter saw will be to take off as little as possible just to square up the end. We then want to measure our board and mark it at 47 1/4. A stop block will ensure these are cut to the same measurement. We can then cut both of our pieces, making sure that we are cutting off the marked end. And this will then yield us two pieces that have a finished length of 47 1/4 by a finished width of 2 inches, and we are still at about 1 inch thick. Taking a look at our plans, we have one bottom rail kick plate. This piece goes in between our stiles. Our total project width without the top is 24 inches. We know that our stiles are 2 inches wide. So subtracting both of those stiles puts this piece at 20 inches in length. The width of this piece is 3 inches, and the thickness will end up being 3/4. Now the only material that I have left measures about 2 3/4 inches wide. I need a piece that is 3 inches wide for my kick plate. Now I should be able to use this piece for my top rail in the next step, but I won't be able to use it for the kick plate. I found another board that I think will work pretty good. It has a width of about 6 inches and a length of about 86 inches. I do have a portion of a knot kind of about right in the middle of the board, but if I flip the board over, that side looks pretty nice. So this knot should not be an issue. Now if I take a look at my parts list, I am working on the bottom rail kick plate. My top front rail should be able to come out of the off-cut piece that I had from earlier in the project, but then I need to make 2 of these top gussets. Now the top gussets are 10 1/4 inches long, and I need 2 of those. My bottom rail is 3 inches wide. My top gussets are 2 1/4 inches wide. Additionally, my bottom rail is 20 inches long. So what I'm thinking is, if I cut my bottom rail kick plate to an oversized length of 21 inches, I should easily be able to get my 2 top gussets that have a length of 10 1/4 inches right next to my bottom rail kick plate. Again, given this board is about 6 inches wide, my bottom rail kick plate is 3 inches wide, my top gussets are 2 1/4 inches wide. So my goal is to cut this to an oversized length of 21 inches. Taking a look at my schematic, the length of my bottom rail kick plate is 20 inches as we subtracted our stiles from our width measurement. Additionally, taking a look at our parts list, we previously determined that if we cut the bottom rail kick plate to an oversized measurement of 21 inches, given that the finished measurement is 20 inches, that should still allow us to get our two top gussets out of the same oversized board. So on our board, we will first square up one end, then measure to 21 inches for our oversized measurement, and out of that piece we can get our 20-inch bottom rail kick plate and two 10¼ inch top gussets. So with this planned out, we can go ahead and square up one end, measure and mark our board at 21 inches, and perform our second cut. And we are left with a board that is 21 inches in length by a little bit under 6 inches in width by about 1 inch thick. Taking a look at our schematics, we can see that the bottom rail kick plate has a width of 3 inches. Now our objective at this point is only to cut the width and not to cut the shape. Our material currently has one straight lined edge and one rough edge. I'm going to take my straight lined edge and run that through the joiner a couple times to clean that up. The table saw will be set to 3 inches plus 1/16, and with my good clean jointed edge up against the fence, I can make my cut. And I am left with one good clean jointed edge, one mill marked edge by the table saw blade, and my offcut piece. I'm going to clean up my mill marked edge on the joiner. This will take off that additional 1/16 of an inch. I now have a finished width of 3 inches by an oversized length of 21 inches by a thickness that is about 1 inch. And for the time being, we are going to leave this at our oversized length of 21 inches and move on to making the top front rail. If we take a look at the schematics, our top front rail is at the very top of our project on the front. This piece measures 2 inches in width, and we can determine the length by finding the total project width, not including the top, of 24 inches, and we can subtract both of our 2-inch wide stiles from that measurement. This gives us a finished length of 20 inches by a finished width of 2 inches by 3/4 of an inch thick. Of the material that I have left, I have one piece of material that I've saved from earlier on in the project. This piece measures about 23 inches long by about 3 inches wide. That should easily yield me my 2-inch wide by 20-inch long piece. Additionally, I should be able to cut out that knot and not have to worry about it. Taking a look at the schematics, I can see that my project width, not including the top, is 24 inches. If I subtract both of my stiles, that gives me a finished length of 20 inches. Because this piece will fit between the stiles, I'm going to want to cut this at an oversized measurement and leave it at that oversized measurement until I get ready to install this. I have a piece that measures about 23 inches that I have left over from a previous portion of the project. 23 inches is a little long. I could leave this at that since I am cutting it down again later, but I want to be just a little bit closer to what I need it to be. So I'm going to measure, mark, and cut this to an oversized length of 21 inches. So my workpiece now measures an oversized length of 21 inches by a little bit under 3 inches by about 1 inch thick. Taking a look at my schematic, my top front rail has a finished width of 2 inches. My workpiece currently sits at a little bit under 3 inches in width. I have a knot on my workpiece that I want to cut out. So I'm going to begin by joining the edge opposite of the knot one time to clean it up. Set my table saw to 2 inches plus a 1/16, and with my good clean jointed edge up against the fence, perform my cut. On my workpiece then, I have a good clean jointed edge and a mill marked edge by the table saw. Additionally, I have my offcut piece, and I was able to remove that knot. I'm going to clean up my mill marked edge on the joiner, which will also remove that 1/16 of an inch. And my workpiece now is a finished width of 2 inches by an oversized length of 21 inches by about 1 inch thick. This piece will also be left at an oversized length until we get the stiles installed on our project, because this goes between the stiles. Taking a look at our plans, we can see that the thickness of our face frame components, the stiles and the rails, are 3/4 of an inch thick. Currently, all of my pieces measure about 1 inch thick. Because we want all of our face frame components to be perfectly flush on the outside, I need to make sure that I am planing all of these pieces at the exact same time so they have an identical thickness. And throughout this process, I am alternating sides so I can plane and clean up both faces of the boards. My objective is to reach 3/4 of an inch to match that finished thickness measurement. And when finished, all of my stiles and rails have a finished thickness of 3/4 of an inch. My front stiles have a finished length of 47 1/4 and a finished width of 2 inches. My bottom rail kick plate has an oversized length of 21 inches by a finished width of 3 inches, and my top front rail has an oversized length of 21 inches by my finished width of 2 inches. Taking a look at our schematics, we can see that the front stiles are attached to the front edge of our project. Although as it is drawn up, our front stiles are perfectly flush with the side of our project, we're going to leave just about a 32nd of an inch overhang when we install these. This little overhang will be able to either be left or flush cut off after installation. we'll begin by applying a little bit of glue to the front edge of our sides. We want to make sure that the glue is spread evenly over the entire surface. We can then set the stile in place and very carefully work down the length of the project, installing a series of clamps, making sure that we have about a 1/32 inch overhang of our stile onto the side. Applying just a little bit of very gentle pressure. The bottom of our project needs to be flush. The top should be flush as well. We then want to wipe any excess glue with damp paper towel. And don't forget to wipe the inside as well. This then needs to sit for 24 hours. After 24 hours, we can remove our clamps and set up for our other side. A little bit of glue and more clamps. Again, making sure that the bottom and top are flush, and we have about a 32 inch overhang down the length of the project. And we can wipe the glue and wait another 24 hours. If we take a look at our schematic, the rails, both the bottom rail kick plate and top front rail, should be a length of 20 inches. However, it is possible that the distance between our two stiles is slightly off. So we are going to verify this measurement to see how close we were. And I'm actually just a hair under 19 and 15/16 of an inch. And I had previously cut my bottom kick plate rail to 21 inches, which was substantially more material than I needed. And to size this down, I'm first going to start by marking each end of my kick plate rail. I'm then going to square up one end by taking off as little as possible. I'm then going to line up my good square end with my left stile and put a mark where that meets my right stile. Now, it is not recommended to follow that same procedure for the top front rail, because the ends of our sides have some flexibility. And this would get us an inaccurate reading if that was bent out or bent in a little bit. So with my top front rail, I'm also going to mark the ends. I'm also going to square up one of the ends by taking off a little bit first. And with the mark previously made on the bottom kick plate, I'm going to set up a stop block to that measurement and make that cut. And if done correctly, this should have a nice tight fit. But then I'm going to use my stop block at the same setting to do my second cut. This will ensure that the sides remain perfectly parallel. If we take a look at the schematics, our kick plate has a portion of material removed. Using a tape measure, we can measure in 2 inches. We can then use a square to measure up 2 inches. If we create a reference point 2 inches up, a little bit further down, we can connect those together. And then taking a lid or some other type of rounded object with a diameter of 2 inches, we can create a 1 inch radius. We can then cut this out on the bandsaw, making sure that we leave the line so we can sand down to the line. A few relief cuts will help us in the process. We can then clean up that radius on the spindle sander, followed by the belt sander for the ends and the belt sander for the length of our longest cut. And with that all sanded, we're looking pretty good. Taking a look at the schematic, our bottom rail kick plate and top front rail are connected to our two front stiles. Because this will be connected with end grain, we are not able to glue this and have a good, secure connection. We will be installing two pocket screws. However, we do not want to interfere with our lower shelf. So our two pocket screws need to be positioned to clear the lower shelf, but still allow us a positive connection between these two pieces. On the top front rail, we do not have that same concern, so we just want these spaced evenly apart. And we can then cut all of those pocket holes. Taking a look at our schematics, we have both our bottom rail kick plate and top front rail installed between our two front stiles. We have sized down our pieces and cut pocket screws, and we are ready to fit this in place. And we want this perfectly flush with the bottom. And before installing the pocket screws, I'm going to install a clamp to help hold the front surface of both of these pieces flush. I'm then going to flip the project over. And I want to check everything to make sure that it is lined up properly. And if I take a look at the inside of the project, at this connection point, I do have just a little bit of a lip on the inside. Now the reason for this is that the 3/4 inch plywood is not actually 3/4 of an inch. It is more like 0.71 inches. So just a little bit under 3/4 of an inch. You could trim this piece down before you install it, or you could leave this minor 1/32 of an inch lip, which is what we're going to do. And if you're good with everything, we can flip the project back over, take everything off to prep for glue. And with our Jorgensen clamps securely holding our pieces flush, we can install a couple bar clamps along the length of this piece. We can then flip it over and install our pocket screws. And we can remove our wood clamps, but the bar clamps need to stay on for 24 hours. With our top front rail, we're going to flip the project back over, set a clamp in place, install our workpiece with just a little bit of light pressure. We need to make sure that we are flush at the top. And then we'll add a clamp. This then can be flipped back over, and we can install those additional pocket screws. And we should be able to remove all of those top clamps. Taking a look at our schematics, we are unable to easily see the top gussets on our multi-view drawing. If we take a look at the exploded view, we can see that the gussets are all the way at the top, all the way on the sides of the project. Those pieces run from the back of the face frame to our top rear rail. If our calculations are correct, these pieces should be 3/4 of an inch thick, 2 1/4 inch wide, and 10 1/4 inch long. Now, of my remaining material, I have my big long board that is left, which was the second board that I grabbed. I have my plywood remnants, which will end up going for the shelves. I then have my one additional piece that should yield me both of these top gussets. If each top gusset is 10 1/4 inches long, multiply that by 2 is 20 1/2. My piece here is about 21, so that should leave me plenty of material. The top gusset is 2 1/4 wide. I am at about 2 1/2, so I should have plenty of material. Taking a look at my schematics, the total width of the project without the top is 12 inches. If I remove the face frame, that leaves me with 11 1/4 inches. I have a 1/4 inch back material. That leaves me at 11 inches. And then I have my top rear rail that is 3/4 of an inch thick, which leaves me with 10 1/4 inches. Because my existing piece is already to an oversized 21 inches, I'm not going to cut this piece to an oversized length because it already is an oversized length. However, I am not yet going to cut this down to 10 1/4 inches until after I run it through the planer, because short pieces through the planer oftentimes don't work very well. This piece, however, will yield me both 10 1/4 inch pieces with a little bit extra to spare. Taking a look at my parts list, the top gussets need to have a finished width of 2 1/4 inches. From previous work that I did, I have one mill-marked edge from the table saw, and I have one straight-lined edge. I'm going to run my mill-marked edge through the joiner one time to clean it up. My table saw will be set to 2 1/4 inches plus a 1/16. And I can then joiner off that 1/16 of an inch mill-marked edge. My top gussets board is now about an inch thick by my oversized measurement of 21 inches by my finished width of 2 1/4 inches. Taking a look at my parts list, the thickness of the top gussets need to be 3/4 of an inch. As it currently sits, my board is about an inch thick. Now it's important that I plane this at its longer state before cutting this down into the smaller finished length pieces, because small pieces don't work very good in the planer. And I can progress down to 3/4 of an inch thickness, measuring it periodically. My board is now an oversized 21 inches in length by a finished 2 1/4 inches width by a finished 3/4 inches thick. This will yield me enough material to get my 2 gussets. Taking a look at my parts list, my top gussets have a finished length of 10 1/4 inches. We previously calculated this, but we want to verify this measurement. We can measure the top of our project, and we can see that 10 1/4 inches is an accurate measurement. On the miter saw, I'm going to start by marking both ends of my board. I'm going to take off as little as possible just to square up one of the ends. I'm then going to measure to 10 1/4 inches, mark my board, and then set up a stop block. And with my good, newly squared end against the stop block, I can cut 2 pieces. I now have my 2 top gussets that are a thickness of 3/4 of an inch, a width of 2 1/4 inches, and a length of 10 1/4 inches. Taking a look at my exploded view of my bookshelf project, the top gussets are located all the way at the top, all the way to the sides. I should be at a point where I can dry fit these into place. Now I will have a glue joint running the length of the edge of the gusset, but I want an additional connection point on the ends of each of these gussets. So I'm going to mark for a pocket hole location. I am attempting to avoid my other pocket hole screws, as well as getting too close to the end of my front stile. And I can cut those pocket holes. We can then apply a little bit of glue and install that top gusset, holding it in place with some clamps. And we want to come back and wipe that glue that has squeezed out on both sides. And we may have to shift the clamps around a little bit to install those pocket screws. And this process can be repeated for the other side of the project. Taking a look at our schematics, The top of our project measures a total length of 26 inches and a total width of 13 inches. This is then listed as 3/4 of an inch thick. My remaining material is 64 inches in length by 6 inches in width. If I cut to an oversized measurement, 2 pieces at 26.5, because these are only 6 inches wide, at max, that will yield me 12 inches in width. That's without cleaning them up. So I still need an additional 26-inch long piece by at least probably a couple inches to add on to this to give me more than my required measurement for the top. Now I did find one additional smaller board. This board measures 27 inches in length, and although I have a couple areas that don't look very good, I should be able to easily get 2 to 3 inches in width out of that board. Between this material, I should be able to get 3 pieces that are more than 26 inches long and have enough width to get more than 13 inches wide. Taking a look at my schematic, the top of my project has a finished length of 26 inches. I will be gluing multiple boards together, so I need a little bit extra material. So I'm going to cut these to an oversized measurement of 27 inches. Making sure I start with a square end first. I can then measure, mark, and cut all of my boards to a length of 27 inches, which is an oversized measurement. And I now have 3 boards measuring an oversized length of 27 inches and varying widths. Taking a look at the schematics, my top has a total length of 26 inches by a total width of 13 inches. I have previously cut multiple boards to an oversized length of 27 inches, and if I line all those boards up, I am just under 17 inches. However, I do have several issues with these boards. I do have kind of a knot or a portion of a knot on one of the boards, and I have some additional defect area on another board. My objective is to get more than 13 inches in width and have all of the edges cleaned up. Starting on the joiner, I'm going to clean up one edge of all of these boards. On the table saw, I'm going to have my good, clean, jointed edge up against the fence, and I'm going to remove as little material as possible so that I can create a parallel edge to my jointed edge. And with that extra board that I had found, I'm going to try to cut off as much as that defected area as I possibly can, yet leaving me the maximum amount of material to still use. Each of these boards have one good, clean, jointed edge and one mill-marked edge. My mill-marked edges, I'm going to clean up on the joiner next, and for my 2 wider boards, that will complete the process for right now. And for my board with all the defects, I'm going to come back to the table saw off the rest of that defect area, and then go back to the joiner and clean this up again. I now have 3 boards with good, clean, jointed edges for all of the edges. If I put those boards together, I have a nice tight fit with no gaps. I have previously prepped all of the edges of my boards, and when fit together, there is a nice tight fit with no gaps. My next objective is to alternate the end grain. As it is right now, each of these boards, the end grain is facing down. I want to make sure that the end grain is alternating down, up, down. Additionally, I want to make sure that the face grain looks nice. On these particular boards, there are some areas where we have a knot or some other defected areas. Here we have another one. I want the top of the project, which is what everyone's going to see, to look as nice as I possibly can. I'm also checking that the grain pattern lines up with each other so that when this is glued up, it looks like it is one board that was never glued up. And when we got everything the way we want it, we're going to number the joints so we know what orientation the boards go when we glue it up. We have previously laid out our boards by alternating the end grain, checking the face grain, and then identifying the glue joints with numbers. We can space out several clamps and place our boards in order. We can then run our bead of glue along the edge and work that around to get good coverage. Make sure we line up our ends as best as we can. And we're going to apply just a little bit of pressure. And then we'll come back with a couple clamps on top. Snug those down and wipe the glue on both sides. This then needs to sit for 24 hours. After 24 hours, we can unclamp our board and hang our clamps up. And any dried glue then needs to be scraped off from both sides. We then have our top, which measures 14 inches wide by 27 inches long by about an inch thick. If I take a look at my schematic, the width of my top is 13 inches. That is the finished width. My glued up top is 14 inches, so I'm going to begin by cleaning up one edge on the joiner. I'm then going to set my table saw to 13 inches plus 1/16, and with my good clean jointed edge up against the fence, make my cut. And then clean up that mill marked edge on the joiner. And I now have my finished width of 13 inches by my oversized length of 27 inches and my thickness of about 1 inch. Taking a look at my schematics, my total finished length is 26 inches. My current length is 27 inches, and since I did glue multiple boards together, both ends of this board are not square. So I'm first going to square up one end by taking off as little as possible. Then I'm going to measure and mark my top at 26 inches and make my next cut. I now have a finished length of 26 inches and a finished width of 13 inches, and I'm still at about 1 inch thick. Taking a look at the schematics, the top has a finished thickness of 3/4 of an inch. However, my preference is to leave the top as thick as possible because this is what takes all the wear and tear. If the top is a little bit thicker, in 20 years we could easily refinish it by sanding it down and still have plenty of material. If I take a real close look at my glued up top, I have a small lip where 2 boards were glued together. I am only going to remove enough material to make this smooth. And with both sides cleaned up, I'm still sitting at about 13/16. Taking a look at the schematics, our pilasters run vertically inside our bookshelf. They run the entire length of the sides from the bottom shelf up to the top gussets. We can also see that they are not right up against the edge. They are sitting back just a little bit. It is also important to note that there are very faint numbers stamped into the pilasters. These numbers will help us determine the orientation as far as which end is the bottom and which end is the top. And having a length of 2x4 clamped to the inside will help me position the pilasters front to back and ensure that the placement of the pilasters is consistent. Taking a look at the schematics, the pilasters run from the bottom shelf to the top gussets. The pilasters that we purchased are 48 inches in length. However, when I measure the distance inside our cabinet, I get a length of 43.5 inches. We first need to make sure that all of the numbers are facing the correct direction, meaning one of these pieces isn't upside down. Additionally, we can double check at the bottom to make sure that the holes line up with each other. If I flip one of these around, we can see that the holes are not the same. Next, we need to mark one of them at 43.5. And I'm going to set up a stop block on the miter saw based off of that one marked piece at 43.5 inches. I'm then going to stack the remaining 3 pieces, gently pushing them up against the stop block. Next, using a board of sufficient size, I'm going to place that on top of the pilasters and clamp that in place, making sure that the end of the board is as close to my cut plane as possible. Now, with having the correct blade installed on the saw and holding my material as tight as I possibly can, I'm going to very, very slowly make a cut through my pilasters. Again, the feed rate of the saw needs to be as slow as possible, and you should have the proper blade for this. And we now have our 4 pilasters cut to a length of 43.5 inches. If we take a look at our plans, the pilasters are installed a little bit back from the face frame. They are also installed a little bit forward from the back of the project. By clamping a 2x4 to the back of our project, we can ensure that the pilasters will be 1.5 inches from the back of our project. Now, before we install any of these, we always want to double check that the numbers are going in the same direction for every piece. So after we know that these are in the correct orientation, we can set them in place. We then want to verify that they are pushed all the way down against the bottom shelf of the project, and we can install our first screw. We want to install this slowly and tighten it just until it is a little bit snug. We can then continue that same process along the length of the pilaster. Now, although the screw locations are every 6 inches, I typically skip about every other hole. That process will then be repeated for the other 3 sides. And with those pilasters installed, we're looking pretty good. If we take a look at our schematics, we have a 1/4 inch back that needs to fit onto our project. We have previously inset our top rear rail 1/4 inch to accommodate the back. We have also cut our lower shelf 1/4 inch narrower, again to accommodate this 1/4 inch back. What we haven't yet done is create a rabbet along the sides to accommodate the 1/4 inch back. Some additional methods to creating this rabbet would be to use the dado stack on the table saw before we assemble anything. When we originally made the sides, we could also have routed a rabbet again before we assembled anything together. The big challenge is knowing when to stop when you're routering, and the dado, of course, would run the entire length. With the project on its face and a rabbeting bit in the router set to the thickness of my 1/4 inch back material, I want to secure my project to the table and make my first cut. And the other side as well. Our 1/4 inch plywood back has square corners. However, when we routed this, it left a radius and some other areas that we need to clean up. Using a chisel and a mallet, we can very carefully work those corners square. Our goal is that our 1/4 inch backing piece will fit nicely in that cleaned up corner. And at the top of our project, we're going to bring this straight rabbet cut all the way out. And that will then accommodate our 1/4 inch back very nicely. With the rabbet, the back of our project measures 23 3/8 by 45 inches. Based on our initial calculations for plywood, we should be able to get the back piece out of 1/4 of a sheet of plywood. Given that a full sheet of plywood is 4 feet by 8 feet, we will begin by cutting it in half. And this will get us material that is 48 inches wide by 48 inches long. According to the cutting diagram, the grain pattern of the plywood needs to run lengthwise with our length measurement, that length measurement being 45 inches. Additionally, on our project, that length measurement, 45, needs to have that grain direction running lengthwise, so it also matches the side pieces of our project, which also run lengthwise. Taking a look at my parts list, I have the width of the back identified as 23 1/4 inches. I need to verify that measurement with my actual project. Now the width of my piece with the rabbet is 23 3/8. I'm going to subtract 1/16 of an inch to give me a 32nd of an inch play on either side of this piece. So I will be setting the table saw to 23 5/16. And then I need to make sure that my cut is going lengthwise with the grain. I can then check my width measurement by placing this on my project. And that fits in there really nice. Taking a look at my parts list, I can see that the back measures a total length of 45 inches. I want to verify that measurement with my actual project. I'm sitting just a shade under 45 inches. So I'm going to cut this to 44 15/16. Now on the panel saw, we want to make sure that the good side of our board is facing the wall. Then we can measure, mark, and cut. And we can then set that in place to see how well that fits. And that fits really nice. With the back cut to size and dry fit into place, everything's looking really good. We want to flip up the project because we want to check the grain pattern of what you see from the front to see if we like that grain pattern or if we want to rotate the back 180 degrees. If I take a look at the grain pattern, I have kind of a V shape. I'm going to take my back and flip it upside down and see if I like that any better. And I think I like this just a little better, so we will install the back with the grain in this orientation. We will be applying a little bit of glue and then installing 5/8 inch brad nails to hold this in place. This should ensure a good strong bond. We want to use a minimal amount of glue so we have virtually nothing to clean up on the inside of the project. A very thin bead should be sufficient. We can then add our back, making sure that it gets seated fully, and double checking that the good side is facing in towards the inside of the project and the bad side is facing towards the back of the project. And we want to angle the brad nails slightly towards the side of our project rather than towards the inside of our project. And then we want to flip it over and look to see if there's any glue that needs cleaned up. And this is looking really good. I do not see any glue that needs cleaned up. And our project looks really nice now that we've got the back on. Taking a look at our schematics, we have 3 shelves. The shelves run between the pilasters. They run behind the face frame, and they go all the way to the back of our bookshelf. And according to our parts list, these should be 3/4 inch veneer plywood, 11 inches in width, 22 1/8 inches long. Of the material that I have left from the beginning of the project, this is the remnants of the half sheet of 3/4 inch plywood. I have one piece that measures about 25 inches long. I have another piece that measures about 48 inches long. The width of my pieces are 11 inches by about 14 inches. With these measurements, I should be able to get all 3 of my shelves out of this remaining plywood. And if we take a look at our cutting diagram for our plywood, that does correlate to what we had planned out. Taking a look at our plans, the shelves run from the inside of the face frame to the back of our project. Knowing that the overall depth of my project, not including the top, is 12 inches, if I subtract the 3/4 inch face frame, that gives me 11 1/4 inches, but I also have a 1/4 inch back. If I subtract that, that gives me a measurement of 11 inches. I want to double check that measurement with my actual project, and I can see that to the inside edge is just barely over 11 inches. Because we will be edge banding the front edge of the shelf, we're going to subtract 1/16 of an inch from our width measurement, and this should give us plenty of room for that edge banding. So I'm going to set my table saw to 10 15/16 and run both of my pieces. I now have 2 pieces that are 10 15/16 wide, and I have plenty of length to get 3 shelves out of these 2 pieces. Taking a look at my plans, I can see that the shelves sit between the pilasters. If I look at my parts list, I have a length of 22 1/8 inches. However, I want to verify this measurement on my project before I cut my pieces. If we measure it, we're sitting right at about 22 1/8. So that number should be accurate. On the miter saw, I'm going to set up a stop block to 22 1/8, and then cut all 3 of my pieces. And I should be able to test this by setting one of my shelves in place. Should fit in there real nice. Taking a look at my plans, the shelves shown are 3/4 of an inch thick, and our shelf material is also 3/4 of an inch thick. However, we have the plywood edge that we need to cover up. So we're first going to cut a piece of veneer edging just a little bit longer than the length of our shelf. We're then going to use an iron to iron on the veneer edging, and then we'll come back with a block and help press that down in place. Then we'll come back and trim off the tails and clean up both edges. And a little very light sanding will finish that up. And that process will be repeated for the additional shelves. If we do a little quick math on our project, our opening is about 42 inches. Each shelf is 3/4 of an inch. So if we take 42 minus 3/4 minus 3/4 minus 3/4, that gives us a total opening minus the shelves of 39 3/4. If we take 39 3/4 divided by 4, that gives us an estimated opening of about 10 inches between each of these shelves. I can then measure up about 10 inches on my pilaster and work one of those clips into position. And with all 4 of those installed, I can see how my shelf looks. And with our 3 shelves installed, everything is looking really nice. If we take a look at our schematic, the total length of our top is 26 inches, and the total width of our base is 24 inches. This gives us a 1-inch overhang on the left side and the right side. If we take a look at the depth of our top of 13 inches and the depth of our side at 12 inches, this gives us 1-inch overhang in the front and the top being flush along the back edge. Now the good side of my top, I'm going to put face down. I'm going to remove my shelves and turn the cabinet upside down. And then my objective is to center the base of the bookshelf on the top, having a 1-inch overhang on the left and right side and a 1-inch overhang on the front. And on the inside edge, we'll put a couple reference marks. Then we can tip the project back. Next, we can apply glue to all of the mating surfaces and install it back onto our project. Lining up our reference marks. And I'll add a couple clamps to the front to hold everything in place. And wipe any glue. Now, because most people will pick up this project from the top, I want to make sure to use a mechanical fastener. So I'm going to drill a 1/8 inch pilot hole, having the bit set so it does not drill through the top of the project. We'll drill our pilot hole, a couple of those, and install a couple pan head screws. And we'll keep the clamps on for 24 hours. With our top on the base and everything dry, we're looking pretty good. The top edge of our project is very sharp, so we will be routering a profile to add a little bit of character and bring down the sharpness of this edge. And with that top edge routered, it's looking really nice. With the top being routered, we are completely done building our project. The last step is to sand all the components and prep this for stain. Areas that have burn marks from the router, we want to sand those out. Any pencil marks for layout lines for our pocket holes, those need to be sanded out, as well as pencil marks for laying out for our curves at the bottom, those need to be sanded off. Additionally, if there are any irregularities in the surface, we want to sand that flush, as well as every sharp edge on the project. We want to break the edge with a sanding block and then come back with some sandpaper and smooth that out. The goal is to put a microscopic round over so it still looks square, but it's not going to chip off over time. And lastly, we just want to do an overall general sanding of the entire project to prep this for stain.